our clients. Yes.
So this is the next. I mean, sorry, Don.
Oh my God, you like preschool? What is it?
Also, the green one is actually
All right, we are going to just jump right into 3.2 today. So taking a look at 3.1, looking at measures of central tendency, how to identify the middle of our data. We're going to be doing in 3.2 is, as fun as it is to talk about the middle, what if we have a data point that's not in the middle? How can we classify that relative to all of the other data points that surround it? This is going to give us the ability to do so, at least for a little bit, at least in the context of how things relate to the medians. When we're talking about measures of position, this is simply referring to where a data point falls relative to the rest of the data. We're going to see three different ways that we can describe the position of data. We're going to focus on two of them today, which are really the same thing. In fact, the words that I will use to describe particularly quartiles are going to be in terms of the other one, which are percentiles. But we'll address all of that in time. The other one is something that we are going to save for a little bit later. But that will kind of make up the bulk of what we will be seeing really for this course. So measures of position, we can talk about this in terms of quartiles, in terms of percentiles, which are really the same thing, or we can see this given in terms of what are called z-scores, which are probably going to be the one that are pretty brand new to a lot of us, and again, we'll get to those later. All right, as far as quartiles are concerned, we have three different quartiles that we can talk about, labeled appropriately Q1, Q2, and Q3. It's a little bit weird to talk about quartiles before talking about percentiles. I'd probably invert the order here because actually the way that I am going to define these quartiles is in the language of percentiles, but we'll get to that momentarily. We're going to focus first on Q2 because we've already talked about Q2 in this class, just not with this particular name. Q2 is just a shorthand way to talk about the median. And this is actually going to give us a pretty robust look as to what we are talking about for the other quartiles as well. How did we find the median for a particular data set? What did we actually do? Okay, so lined everything up in terms of value order. And then what? What were we looking for? Yeah, like the literal center of the data. So average is kind of like pooling all of our data together, doesn't necessarily care all that much about like the individual values of data, whereas the median is a lot more working with kind of the data points that we are given, just looking for the one that is in the middle. If we find the data point that is in the middle, how would we describe it relative to kind of the other data points in the set? For instance, what percentage of our data should this median be larger than? what would we expect? You'd expect it to be half. So in terms of a percentage, that would be 50%. So the median, which we can think of as being like 50 or larger than 50% of the data. Now, conversely, what would we expect the median to be smaller than? How much of our data? The other half, the other 50%. So we could kind of frame this in like a being larger than some amount, being smaller than another. And ultimately, we'll see that that is a valid way to approach percent or this metric here, which what we are describing is a percentile. Again, we'll get into it a little bit more later. But generally, the kind of nomenclature here is that this 50% here saying how much of the data are we larger than? How much is to the left of this particular value? And kind of like I've been hinting here, the other way that we would describe this is that this is the 25th, or not 25th, good night, the 50th percentile. Right, so saying that we are larger than 50% of our data, equivalent to saying that this value is the 50th percentile, the dead center. Q1 and Q3 are very, very similarly defined. So for instance, Q1 I might describe as the 25th percentile. Again, we can kind of see like, why are we talking about quartiles before we talk about percentiles if it's part of the definition? What would it mean to be the 25th percentile based on how I defined it for median? Yeah, so how much of our data is to the left? 25%. So about how far are we through our data in terms of like fraction? A fourth of the way through our data. Cool. And then Q3 is going to, any guesses for Q3? 75th percentile, which would be like, how far are we through our data? 3/4 of the way, 75% of the way through. 75% of our data about should fall to the left. And we would expect about 25 to fall to the right. We're going to see with small values of n that number doesn't quite hash out to be perfect, but we'll see it's serviceable enough. It gives us a good enough idea of what we're referring to. All right. Part of talking about quartiles is going to be coming up with what is called the 5-number summary. This is, well, for one, we already have 3 of those numbers. These are the 3 quartiles themselves are kind of the middle of this. Essentially, think of this as just like counting up by quarters, going all the way through by fourths. So we have the 25th, the 50th, and the 75th percentiles. What 2 are we missing for our 5-number summary? 0 and 100. Cool. So for the 0th percentile, which technically speaking, the 0th percentile doesn't really exist, but like we're good enough. We'll deal with that when it comes up. Hopefully never. What value from our data set? So I gave you a data set. It's full of all sorts of random numbers. We are looking for the number that is larger than 0% of our data. What value from our data set is going to be larger than 0% of our data? It is smaller than everything else. Well, there's going to be one value, and it is the smallest value. Very good here, Merrick. The minimum value is going to be what we will kind of call for now the 0th percentile. Okay, so starting at the min, which is like starting at 0, there's nothing to the left of this. Working our way up to the 25%, which is Q1. D5th. And then we saw the median. I'm going to refer to it as the median, not Q2, because it's embarrassing to call it Q2. And then Q3, which is our 75th. And then what value, what data point is going to be bigger than 100% of all of the rest of our data? The biggest number, the maximum value, is going to be bigger than 100%. Now, important there, and I think this is to Dylan's point, why he said none. is that I'm saying that it's every other data point, right? So we kind of don't include the value that we're looking at itself for this comparison. So for instance, if I asked you what value is smaller than all of our data, just period, the minimum isn't smaller than the minimum, right? The minimum is the same size as the minimum. But when we ask smaller than all other data points, now all of a sudden we get to use the minimum for that metric, which is that 0th percentile, which again is a little bit of an asterisk on that 0 and 100, but we're going to run with it and say that that's serviceable enough. All right, questions with our setup here with our 5-number summary, kind of what we're looking at. All right, let's look at this in action. The good news is if you do put all this into a list and do one variable statistics, it'll give you these 5 numbers at the bottom there. But I do want to show you how to do this by hand. It's not particularly tricky. It's maybe just a little bit annoying in the same way that finding the median is annoying. Cool. So we are going to, this one's actually already nice and set up for me. In this case, we are given a set of data, trying to figure out the 5-number summary, and then we're going to create what is called a box and whisker plot to go alongside that. All right, we could do this by hand. What do we need to do first if we're going to be talking about like the medians and these quartiles and all that? Order it, but why would we do that when we can let our calculator do it for us? So enter into L1, stat, sort, all that fun stuff, sort A, L1, and then you get all of your numbers in order, which is nice and lovely. So again, entering in the data into L1, stat, sort A, does the sorting for you. Very, very nice. When we do this, I get 14, 16, 2 17s, 20, 21, 22, 26, 28, 29, and 35. And so what do I have to do to figure out the median? Well, that would be the average. So the median would be figure out the one that's in the middle. So just crossing off until we get to the center. This one, because we have an odd number of points, actually does have a true center. And so the median here is going to be 21. All right, so Q1, the 25th percentile, should be perfectly in the middle of the 0th percentile and the 50th percentile, right? We would expect to find 25 kind of perfectly in the middle there. So what we are going to do is we're going to take the lower half of our data, not counting the median, and we're going to find the middle value there, and that should be the 25th percentile here. So not counting 21, I have 5 values here for my lower half, which is going to be 14, 16, 17, 17, and 20. What is the median of this lower half? 17. This is our Q1. Likewise, we're going to do the same thing with our upper half. So this is what, 22, 26, 28, 29, 35. So for our upper half, this is finding Q3. What is our center? 28. This is Q3. What is our minimum value? 14. And then what's our max? 35. Cool. Again, if you go to stat, slide over to calc, one variable statistics, scroll all the way to the bottom, you get exactly this. The minimum value of x is 14, Q1 is 17, median is 21, Q3 is 28, and the max is 35. So nice and simple there in the calculator. So stat, calc, one variable statistics using L1. Down at the bottom, all 5 of those. But they're not like too horrible to figure out otherwise. All right, for this kind of process, when we actually have the median as a data point, so like here, 21 was the data point. It was definitely the median. It's not like we were tied for anything. Then we don't use it for either half. But what do we do when we cross out everything and we end up with 2 values in the center? How do we find the median? Add them together, divide by 2, find the average of those 2 values. The lower value would count towards the lower half. The upper value would count towards the upper half. So if you end up in a situation where the median is not something taken straight from the data, but is instead something gotten by adding 2, dividing by 2, then the smaller value is going to match with this. The upper value is going to match with that. We'll see an example of that here in a second, but did just want to give you a heads up there. All right. For our box and whiskers plot, this is essentially just going to be a way to visually communicate what we have here on a number line. So I'm going to count up by 2s here. We'll say this is 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. All right. And we are going to plot the 5 values that we have found. We said the minimum value was at 14, then at 17, so 14, 16, halfway is going to be 17, and then the next value at 21, so 18, 20, 21, 22, 24, 26, 28, and then all the way up to 35, like so. The box is the middle 50%. So what is going to be the middle 50% here? From what value to what value? Yeah, so from generically, it would be from Q1 to Q3, and specifically, it would be 17 through 20. We will also include where the median is, another line just to communicate, hey, this is where the center of our data is. Kind of like, I don't know, I guess like a magnet or something. The whiskers are going to be the outer 50%, which is to say from the min to Q1 and from the Q3 to the max. And very simply, we are just connecting, and then like what we saw with the median, putting a little line here to denote that in fact that is the minimum. Like so. The only other thing to worry about here, as far as vocab is concerned, is called the IQR, or interquartile range. So I could say it in either way. If you are asked to figure out the IQR of a particular spread of data. This is what you're being tasked. Interquartile range. Prefix inter, meaning between. Interquartile, so between the quartiles. What range of values are we probably referring to here? From what to what? So from, that would be like inter extrema range, where we are going from min to max, but for the interquartile range, yeah, in between the quartiles, in between Q1 and Q3. And in particular, we're looking at the range of values in between Q1 and Q3. For this particular example, how much space is there between Q1 and Q3? Q1 and Q3? Each hash represents 2. So 11. How do we get 11? Yeah, so each tick mark representing 2, and we like are halfway in between tick mark. So in this case, absolutely, 28 minus 17 tells us that there is a space of 11. And so we can find the IQR very easily by just doing Q3 minus Q1. All right, questions here with our quartiles, with our whisker and box plots, with IQR, anything that we've covered so far? How are you feeling? Hopefully stuff that we've seen before. I would say this should hopefully be a lot of it. All right, take a moment to look at the data that we have here. We're just going to take like 5 minutes. You can do this in your calculator if you'd like. That's totally fine. Take a moment to figure out the 5 values, min, max, Q1, Q2, Q3, and go ahead and sketch the plot here. Not looking for extreme precision, but sketching the plot. Then you would also count, so this is perfect, and then because this like the middle value here, we would count as another. Yeah, that was perfect. Yes. Yes. Yeah, so if you go to stat. Yep, go cut. It doesn't even need to be in order for this. Go one variable statistics, enter, enter, enter. And then you scroll all the way down to the bottom. All 5 of those values are the ones you want.
If there's 2 for the median,
yes.
What do you do for the low? What do you do for the median?
So you would do all 4. So it's like everything to the left of the median and everything to the right of the median. So you would count the value that you used to get it, because it still falls to the left in that value. And then likewise with the left, you say for the others. That's a good question. Yep. Good question.
I bet you I'm still doing that. What's that?
So do you average these two, or do you just take 90?
So if we were just counting these three, we would just be taking 90. But we are going to count this as part of the like upper. So we're going to average the 80. Likewise, if we were not counting 82, we would just take 71. But because we do want to count 82, we're going to take the average. So, yeah, good question. That was good. Can you grab a pass?
How many did you go up?
Have fun.
Actually, I left my bag with like cookies in it down in nursing.
Yeah, I
Whenever we go.
We'll have a lot. Yeah. Small things.
Yeah. Yeah. Make sure you're there. Yeah, I know. Oh my gosh.
All right. So as far as arranging our data goes, I got 45, 71, 79, 82, 88, another 88, a little bit more space here, 88, a 90, and a 94. What is our min? 45. What is our Q1? 75. Not a value that we actually see, but the average between 71 and 79. Very good. What is our median? 85. Again, another average. Our Q3. 89. And then lastly, our max. 94. Very good. And our box and whisker plot. We're just going to do this. I will give you on, say, like hypothetically, like a quiz that we have on Monday or something. I would give you a number line to use for this. So yeah, so you won't have to like draw the number line. You'll just need to overlay. You'll need to label it. Like you'll need to tell me what values or what. Noticing here that the median is a little bit closer to Q3. So something like this.
14 out of 80, right? So, wait, for the lower one, do we include like 82?
Yeah, so you would include 82 in the lower and you would include 88 in the upper. Yeah. Yep. So this is 45, 75, 85, 89, and 94. What do we notice about our data? How is it clustered? How would we describe the spread of our data here? Skewed to the left, most of our data focused on the right-hand side, but a few data points dragging us to the left. So definitely skewed to the left. Very good. And then what would the IQR be? 14, which we get from 89 minus 75 equals 14. All right, questions here with our stuff. And again, you can also get all 5 of these using the calculator, and that's fine. That is totally fine. But I did want to demonstrate how to. Okay, so IQR. This value is actually the one from this, or one of the ones from this, that we are going to use for our computation here. In particular, think of the IQR as telling us, again, it's like how far apart 50% of our data is. That central 50% of our data. We are going to use it in order to compute whether or not a point should be particularly surprising to us, or whether it falls within kind of normal expectations of data that we are gathering. So kind of think of this as like similar to hypothesis testing, of like, we're not going to be doing hypothesis testing yet, but similar to it in the idea of, is what we are looking at normal? Would we expect to see something like this for this distribution? Or is what we are looking at what is called an outlier? So outliers are going to be data points that are significantly different than the rest of the data. So like maybe most of our values are clustered around 70 and we get one data point that says 10, or like 3 data points that say 10 out of like 100, something like that. Or maybe most of our data is clustered around 4 and we get one data point that says 50. Right. Now those are pretty extreme examples, but we're going to see actually a way right now to tell is something an outlier or not using the IQR. What we are going to do is we're going to do 1.5 times the IQR. And that is going to give us essentially how far away from the middle 50% we are allowed to be before we get considered an outlier. So anything further away than this is going to be classified as an outlier. Computationally, what that means is if we are 1.5 times the IQR less than Q2, or not Q2, but less than Q1, or 1.5 times the IQR more than Q3, then we are classified as an outlier. Okay. Let's take a look at our, thinking back to our first example here. What was our Q1 and our Q3? And our IQR while we're here? For the first, yeah, for the previous one. We'll do the second one here in a second. 17, 28, and 11. Right idea. All right. 1.5 times 11. Plug it into your calculator, about 16.5. Actually, not about, exactly 16.5. And so we will have any outliers if we are less than 17 minus 16.5, which is 0.5. Or we will have any outliers that are greater than 28 plus 16.5, which is 44.5. Did we see data points that were either less than 0.5 or more than 44.5 for our first example? Did we see anything that we would classify as an outlier? No. What was our minimum value? 14, so nothing less than 0.5. What was our maximum value? 35, so nothing more. So our first example had no outliers. Everything was fairly normal. Nothing crazy. All right, we can run the exact same calculation for our second example, for example 2. What was our Q1 for example 2? 75. What was our Q3? Q3 was 89, and our IQR was 14. What's 1.5 times 14? So 14 and then half of itself is 21. So we are saying that 75 minus 21, which is 54. Anything less than that would represent an outlier. And then 89 plus 21, that's going to be 110. Anything more than that is going to represent an outlier. Did we have any outliers, anything less than 54 or anything more than 110? Yes, what did we have? 45. So 45 is an outlier. Yes.
Q1 is 75.
Yeah, so Q1 from this example that we did here was 75. Q3 was 89, the interquartile range 14, and we're looking for 1.5 times that interquartile range above Q1, 1.5 times that interquartile range below, and anything outside of that is deemed an outlier. Again, just for clarity, where did I get this 21? 14 times 1.5. 14 and then half of itself, 21. Okay, so this next little bit wants us to actually remove this point. We're saying it's significantly different than kind of what we saw. So what happens if we just remove it from our data and analyze the data afterwards? What kind of values change? Do they change significantly? And what I want us to notice, you're more than welcome to kind of run this yourself, but if you just delete from your kind of data here that 45, our new min changes pretty drastically. It's now going to be 71. Our new value for Q1 is going to be now 79. Q2, the median, is going to be 88 with just how things kind of shift around. Q3 is going to be now 90. And then the max is going to be 94. So stuff changes a little bit, right? Everything basically shifts over by 1 point, right? If we cover up what's going on here, right? If we're ignoring this, then every other measurement that we take has basically just shifted over by a tick. Okay. Not too horrible there. But the thing that I want to kind of really stress here is that while our median value and kind of those metrics that are associated with the median, other than the minimum value, we saw the minimum value got raised quite a bit. While these did not change very much, they changed a little bit, but they didn't change very much. So these change slightly. If we were to compute the average, we would see a larger change. Now, in this particular case, it turns out that it's like a change of like 5. So it's not that significantly different than the other ones that we were looking at. But in general, when we have outliers in our data, the mean can change pretty drastically. Because the mean is taking into account every single value when trying to guess where the middle is. So if we throw in one value that's really, 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 really big, or one value that's really, 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 really small, the mean is going to treat that value like every other value that is being measured. It is going to drag the mean in that direction, right? This is what the kind of idea of skew is talking about. When most of our data is clustered on the right, but some outliers on the left are dragging us that way, it shifts the center. It pulls the center to the left. It skews the measure to the left. right? The median is a kind of insulated against outliers, right? All the median changed was we shifted our frame over a half notch, and that was all. Not really anything particularly drastic happening to the median, as long as the median wasn't sitting like right between two values that were pretty different. Certainly possible, and somewhat what we saw here, why there was actually such a large change in the median, but not exactly nearly as drastic as what you would expect to see with the mean. So the mean, as a measure of center, very, very susceptible to outliers. The median, a little bit insulated against what those can do. If we look at how the plot changes, so we saw here was our including the outliers. When we ignore the outliers or graph the outliers as kind of their own separate point, you'll notice that the plot kind of condenses when we actually remove the outlier. Doesn't necessarily change all that fundamentally much, but certainly does condense a little. We already said for our second set, we've got like the center over here, a large, like 50% of the data really, really close to the right-hand side of that center. So the rest of the data kind of pulling it to the left. We said that this was left skew. How would we describe this first distribution? Where's most of our data? Most of it's on the left, and so we would be right skew. Very, very good. Notice here, center, and since we're closer to the left-hand side here. And then for this last one, where does most of our data live? Most of the data lives on the right, and so this would still be left skew. Yeah, very good. Again, think of that middle line in the middle of the box as that center. Most of the data, 50% of that data, is pretty close on the right-hand side, pretty clustered, or it's a little bit more spread out here. Very, very spread out here. Oh, it's still a little bit spread out. All right, questions about outliers? One final point that I want to make is that this process of removing an outlier like this, when we are doing it in this way, is pretty okay. Like, this is fairly acceptable, right? Saying that for the most part, our data looks like this, but hey, we have a couple of points that are over here that are behaving in a slightly different way than what we see. That's fine. But we want to be a little bit careful when it comes to fully disregarding or like completely throwing away outliers from our data. Right? We don't want to start like cherry picking values that are giving us a result that we're trying to expect. We want to keep all of that information there. So you'll notice that even when we quote unquote remove the outlier, when we run this kind of analysis a second time, we still include that there was an outlier. Right, we're just doing the process without it. It's separate. It's sitting over here on its own. So I think an important point to make, that when we are removing the outlier, it's not like we're throwing it away. It's still here. It's just not connected. It's different than all of everything else that we have seen. This is the main trend. Oh, by the way, though, there's something weird going on over here. Okay. One more idea, and it is something that we've already really addressed, already talked about, and that is going to be percentiles, which I've been using the language of percentiles this entire time to talk about quartiles, so this should go pretty quickly. What did it mean to talk about the median as like the 50th percentile? Something else? So being the 50th percentile means greater than 50% of all of the rest of our data. What did the 25th percentile mean? Greater than 25% of our data. So what would we think the 17th percentile would be? Greater than 17%. You'll sometimes see this written as like P sub 17. I think often it's with a capital P, but that's just saying that it's the 17th percentile, which very simply just means greater than 17% of the data. Conversely, what else could it mean? Smaller than 83%. Now there is a problem, not with that interpretation. That interpretation is great. But there's a problem numerically when we are saying that this exact value is greater than 17%, or this exact value is greater than 83%. In order for both of those to be true, how much space does that one data point need to occupy? In order for it to be greater than 17% and less than 83%, how much percent can that one data point contribute? None. There's no room for it to contribute that any data. Okay, so this is a little bit nuanced. This is maybe a little bit more than what I was able to go into with some of my other classes, but I do think it's kind of a cool point here that I want to make, and it'll help make the formula for this make a little bit more sense. This is not an issue when we have a whole bunch of data. Like if I have 1,000 data points and I'm looking at like how much percentage a single data point is contributing, it's like 0.1% is what we're talking about in terms of like what that width actually is. That's not super significant. If I had 10,000 data points, this kind of stops becoming a problem. But let's say I have, we'll say 10 data points here. Okay, so 10 data points here, already ordered, and I want to know the percentile that fits with this one that I've circled here, the 6th data point. All right, so let's run this calculation based on our intuition. How many data points is this particular value greater than? How many is it greater than? Like in terms of a count? It's greater than 5 out of 10. This is greater than 50% of our data. Okay. How much is it less than? It's less than 4 out of 10, which is like 40% of our data. So somewhere in between the cutoff of this and our data point, we do have this 50 percentile mark. And then somewhere between that data point and where we start again, we see like the 60th percentile mark. So our data point kind of fits snugly between these two values, right? We're like, we've got 50% on the right and we've got 40% on the left. So the actual percentile should be somewhere between 50 and 60. What would maybe a good representative value be to communicate that I'm somewhere between 50 and 60?
55.
Maybe 55 is a good way to say that this is the 55th percentile. The average of that 50 and that 60. And that's kind of what we do, right? Again, this doesn't really become an issue if we have like 1,000 data points. Then all of a sudden we can have basically 83% on one side and 17% on the other. Removing one data point from that isn't going to matter. But notice here, it's not quite as simple as just count everything on the left and take the percentage that that represents, and that's your answer. Right? 50% should actually fall like right in between the 5th and the 6th mark, right? This would be the median, somewhere like right here. That would actually be the 50th percent. The 6th value is going to be somewhere between the 50th and 60th. I think 60th is also an okay answer for it. I think that's a really good guess. Certainly, it might be, it's somewhere between 50 and 60. So we say 55. Now, there is a formula for this, and the reason why I'm kind of going through this is just to explain a little bit a piece of the formula. It's not quite as simple, again, as just taking like the amount of data prior to the point that we are considering. You do that, and then you add 0.5. And then you divide by the total. Which is the same as n. The 0.5, again, is just to account for the fact that, hey, we might not be perfectly right at this value. Maybe we're in between two values. So that 0.5 is basically that slight adjustment that you see. Again, we could think of that 0.5 matters less and less and less when these numbers get really, really big. So that plus 0.5 matters a lot when the numbers that we're working with are like 6 and 10 and like very small numbers, and it doesn't contribute as much when the numbers are like 300 or 1,000 or 10,000 or anything like that. Still contributes a little bit, but not a whole. That 0.5, again, that's just like our adjustment term to say, well, technically we're going to be between two values here. There is space that this occupies, and that 0.5 is trying to list that, take that into account. All right, let's see this in action. We are given a list of test scores here. We are trying to find the percentile score for, or the percentile for getting a score of 12. What do I have to do in order to talk about kind of the percentiles and medians and all that? Say again? My mind is like slipping over the word that you said. Numerical order. Perfect. I just literally like brain was not able to process. Perfect. Put this in numerical order. Again, you can have your calculators do this. 2, 3, 5, 6, 8, 10, 12, 15, 18, 20. Okay. How many numbers are to the left of 12? We got 6 of the 10, and so we take that 6 plus our little adjustment term divided by 10. That's going to give us a decimal. In this case, it gives us the decimal 0.65. How would I write that as a percentile? 65th percentile, multiply it by 100, 65th percentile. All right, we've got 60% of the data to the left, 30% of the data to the right. We're sitting somewhere between the 60th and the 70th percentile. We'll call it 65. All right, how many data points fall to the left of 3? 1. Again, we have this little adjustment term divided by 10 times 100. What percentile does this represent? The 15th percentile. And percent is not the way to write it. It's the 15th percentile. Okay. First of all, before we take a look, I want to look at one more example just because it shows up on Pearson and it uses a slightly different way to go about doing it. Any questions here? With what percentiles? Okay, what if we have a repeated value? For instance, let's take a look back at our original data set here. We've got 14, 16, 17, so on. We had, what was this? This was 11 values, right? 5, 5, and the one in the middle. That's not too bad. I want to know what percentile 17 is. Okay. We immediately run into an issue of what do we do with the repeating, right? What do we do with what's going on with the repeating? But let's try and logic through this using kind of our understanding of how we've set up percentiles so far. We've got our 2 spaces, we've got 17, we've got our other spaces. How many spaces are less than, how many data points are less than 17? 2 out of not 10, it's a little bit more, 11. This is about 18.2%. Okay. How much data is, so we've got 2 to the left, we've got 2 with 17. How much data is going to be to the right? 7 out of 11, which is going to be roughly 63.6%. Okay, which, if we're thinking about like what this barrier means, if 63.6% is to the right of the barrier, then maybe this would be what, like 36.4 here. So we are living somewhere between the 18.2 percentile and the 36.4 percentile. Okay, that doesn't seem too bad. What logically would we do in order to say where exactly this is going to fall? Yeah, add them and divide by 2. Take the average of these 2 values, and that'll be like a nice representative value for about where we are. Okay, 18 plus 36 is going to be, what, 54.6? 54.6 divided by 2, 27.3. Third percentile. I think that is great. I think that's awesome. I think you can circle that answer. I would be happy if I gave you like a trick question where there were like a whole bunch of data points. If you came to that conclusion, fantastic. I give you full credit. There's one problem on the Pearson that does this, right? Gives you, it's like number 16. On the Pearson, where it gives you like 50 data points, and the one it asks you to talk about is a repeated value. So like exactly what we see here, it asks you for the percentile, and the answer that it wants is this. Is a 36.4. Don't know why. I think that is less correct than 27.3. 27.3 does a better job of showing the upper and lower range, right? Again, it's the average, it's the middle of what those percentiles could be. But just giving you a heads up that on number 16 specifically, it's looking for the upper bound on what the percentile could be for some reason. It doesn't communicate that in the question. The percentile formula should work for all of the other ones. It is just for number 16 that it does not. But this is what's cool. All right, questions with 3.2? So 17 is not Q2, 17 is just the value that we were looking at. It's, okay, question of like which quartile this would then fall under. Yes, 17, notice, was Q1, which was the 25th percentile, right? But that's consistent, right? That's consistent with the idea that 17 should be somewhere between the 18th and the 36th percentile. Right, so Q2 does fall within this range, therefore 72 would be considered Q2. Or 17 would be considered Q2, rather. Or not Q2, Q1. Oh my goodness. Brain melt. Yeah, so the 25th percentile here, falling in between the 18 to 36 range that we gave. So yes, that makes sense that would be Q1. And then what I said about like the 0th percentile, again, not really being fully correct. If I'm looking at the first number, how many values are to the left? 0. How many are to the right?
11.
If I'm looking at a value, so not counting the value itself, how many are to the right of that value? So 10. So it would be somewhere between like 0% and 10%. So we might call it 5%, even though I classified it earlier as the 0th percentile. There can never be like a true 0th percentile, but it acts like the 0th percentile. All right. Well, that is all I have for today. We've got about 25 minutes left. You guys are welcome to take a stab at the 3132 classwork. If you have any questions that you would like to go over, more than happy to take a look at any of those. I forgot to mention this with my other classes, but while I'm remembering, I'll mention it here. Very well done on the tests. Very happy with what I saw. I think the average, it was like very close to what the Unit 1 tests were, and the Unit 1 tests were great too. So very, very well done. You guys should be very pleased with that, which is good. Absolutely not. Yeah, you're good.